Hello everyone, welcome to Tech with Machines. Our today's topic is Docker architecture. In our previous video, we talked about containerization and all the associated terms which relate to containerization. One of them was Docker. Docker is a platform or a tool that allows the build, deploy, and management of containerized applications. If you recall it, if you haven't yet seen my previous video, please go and check out what does containerization mean and how Docker play a role in that. Today's topic is more about an in-depth understanding of Docker architecture and what are the internal components of Docker which actually play a pivotal role in the way Docker works. So it is of course designed in such a way that it provides a consistent environment for a rapid development, deployment and testing. As you can see on the right side, it has been grouped into three main things. We have a Docker client, we have a Docker Daemon, which is a part of the host group because Docker works as a client server architecture, and then we have a registry which actually takes control of images. Also, we have Docker Composer and Docker Swarm and what role they do play. Let's explore that in a bit. Let's first start with the first thing. As in our previous slide, we saw that there is client and there is host, but all of them are part of the core component of Docker, which is called Docker Engine. So Docker Engine is the core component which is actually basically responsible for creating, running and managing the containers. And in that there are three parts specifically. The first part being Docker Daemon, which is basically part of the host group which we saw in our previous slide. And what it does is it is a background service which is responsible for managing Docker objects. It listens for the API requests and processes them. For example, when you are running docker run command, that command goes to Docker Daemon so that it can process it. And who sends that command to Docker Daemon is Docker client. So Docker client is the command line interface that actually interacts with Docker Daemon through Docker APIs and sends these commands through the API. Either it can be on the same host or a remote one. And REST API is actually the Docker API, which is a communication link between Docker client and Docker Daemon, and it provides access to the Docker's functionality and programmatically. Finally, after these three parts, after the Docker engine, which comprises of these three main components or these three main parts, we are also talking about Docker objects, which Docker Daemon is responsible for managing. So in Docker objects, the first thing which comes and plays a role is images, because those are the ones which are actually being deployed in containerized environment. So they are read-only templates. They are used by creating, by defining the step-by-step instruction in Docker YAML. They contain the application code, they contain the runtime libraries, environment settings, environment variables, and the files which are required to run the application. They are, as has been noted down, built using files called Docker YAML. The second main thing is containers. They are the runnable instances of Docker images. They again package everything which is needed or which is required to run the application in runtime. Again, as if you remember, containers are isolated from each other so that they can run independently. And in this way, there is a consistency across different stages of development by ensuring that there is isolation or the containers are isolated from each other. Then the main thing of the interaction is networks. So Docker networks enable communication between containers. Again, the containers are assigned or the pods are assigned unique IP within a container, and the way they communicate is through network. So there are several types of networks which Docker provides, it being bridge, it being host, overlay, and it suits different configurations and use cases. We will go in depth through what are these types of networks, but to understand the Docker internals, this should be enough. Then the volumes which are used to do the persistent storage in Docker, they allow data to persist when containers are stopped or deleted, and they can be shared between multiple containers as the storage disks which can be mounted to a container. Finally, Docker Hub is the main central cloud-based repository where users can create, share, or store Docker images. It acts as a centralized repository, we can say, or it's a resource for discovering and distributing Docker images. Users can actually push their images to Docker Hub and pull officially from community images, or pull official images or community images from it, right? So there are two types of repositories in Docker Hub, one being public repositories which are accessible by anyone and can be freely used and shared. Others are private repositories which are of course access driven, they are restricted, and they are accessible only to specific users or teams who are controlling them. Then there are other two main components. One is Docker Compose, which actually helps to manage multi-container Docker applications. You can use Docker Compose YAML and you can actually configure all the applications, dependencies, services, networks, volumes, and then using a single command like Docker Composer app, you can create and start all the services from your configuration. If you have applications that are dependent on each other, you can actually basically deploy them as single composer file, Docker Composer. Then there is Docker Swarm. Docker Swarm is Docker's native clustering and orchestration tool like Kubernetes. Docker Swarm is a Docker's clustering and orchestration tool. It allows you to manage a cluster of Docker nodes as a single VM, and it enables the scalability and redundancy. It comes in two ways. One is being swarm mode. When Docker is in swarm mode, you can deploy services that span multiple Docker nodes. It includes features like service discovery, load balancing, scaling, and desired state management. In Docker Swarm, service is the definition of the desired state for a group of containers, and a task is a container managed by the swarm to fulfill the service requirement. So in a nutshell, by understanding its core components, we can effectively leverage Docker to streamline their application workflows and improve the consistency and reliability of our deployments, right? So this hope gives you a comprehensive understanding of Docker architecture, and you will be able to now better understand how Docker plays a pivotal role in your cloud native applications. Thank you so much for watching. I hope you enjoyed the video, and if you did, please remember to like and subscribe.